The new leave system concerning room specialists has presumed that utilizing our most recent 11 billion drive, it would take a phenomenally significant time frame before this try turns into a reality. In the event that all that returns as arranged, the journey to Proxima B is supposed to take around 20 years. Thusly, it will be a really long time before we can estimate about the presence of life on that planet. The profound space telescope has been vital to investigating whether we are genuinely alone in the universe, consistently offering proof through its revelations. The James Webb Telescope has identified some entrancing human-like objects a long way beyond Earth, bringing us closer to noting this significant question. Our quest for life beyond Earth has been a continuous drive across all human activities to such an extent that we have made various speculations and media around it. Our interest with our job, what's more, importance in the universe, stays constant. It's deeply implanted in our nature to look for a friend persistently, regardless of how similar we may be. This drive impels us toward tracking down answers, but regardless of whether we draw nearer, might we at any point be certain we're truly these answers we're searching for, or are they just interruptions? Join us as we dive into the gradual revelations made in the domain of universes and planets on the journey to uncover something we may not be prepared to witness: the far-off lights of different universes. Researchers may have uncovered the most significant revelation in history back in 2021 when the James Webb Space Telescope was being planned. A somewhat striking and theoretical request arose about the capabilities of our technology. The inevitable issue was whether later on, our telescopes could identify artificial light on far-off planets, for example, Proxima B, the nearest exoplanet to Earth. Proxima B, arranged around 4.25 light-years away, was thought to be tidally locked, having one side continually facing its star while the opposite side remains in unending darkness, similar to our moon. A theoretical innovative development might actually transport energy from the day side of Proxima B to its night side using solar panels that produce power from starlight. A study involving researcher Manis Ving among the benefactors showed that an exceptional mix of solar cells on the day side could be connected with future telescopes. This is especially relevant now, as the James Webb Space Telescope has been developed, and it would permit us to expand our search for artificial light on exoplanets like Proxima B. In fact, the reality that the James Webb Space Telescope had the option to do this precise task in 2024, using its higher resolution and improved capabilities, is significant. The telescope could have already identified the lights we were looking for, potentially guiding humanity into a new era of scientific exploration. We ought to dive further into the universe of exoplanets and systems to figure out how this noteworthy accomplishment was made possible. The mission of the James Webb Space Telescope, JWST, to investigate Proxima B is rooted in humankind's deep-seated curiosity about the universe. Starting from the dawn of written history, humans have considered the potential outcomes of our position in the universe, who we are, where we come from, and where we are going. These ageless yet significantly challenging questions have been the focal point of human inquiry for hundreds of years. With the advancement of modern technology, one wonders whether we are any closer to answering these pressing questions. If you somehow manage to ask a philosopher, they might suggest that we are only at the very beginning of truly understanding our reality in the universe. On the other hand, if you asked an astronomer, they would eagerly share the most recent revelations made about the universe using state-of-the-art tools. These instruments, however often disregarded by the general public, are a direct reflection of human advancement. We now have the world spread out before us, and it's the perfect time for us to extend our horizons and handle the universe with the same confidence. One such way to achieve this is through the endeavors of astronomers and space specialists who have been instrumental in developing new technology for the discovery of what may possibly be light on far-off planets. The James Webb Space Telescope, an artifact of human development, is vital to this mission. This infrared space telescope has started addressing these long-standing questions, pushing the limits of what is possible in space exploration. You may be wondering, what exactly is Proxima B? Sometimes referred to as Alpha Centauri, Proxima B is a super-Earth exoplanet that orbits an M-type star. To explain, super-Earths are planets that are more massive than Earth but less massive than ice giants like Neptune or Uranus. They are remarkable in that they can be made out of gas, rock, or even a blend of both. Their sizes can vary, with some being twice the size of Earth, while others may be several times larger. Proxima B fits the definition of a super-Earth and is classified as an exoplanet, meaning it orbits a star outside our solar system. The first expected proof of an exoplanet, however, was found as early as 1917, but it didn't generate much interest. It wasn't until 1992 that confirmation came with the first confirmed exoplanet discovery, which astonished scientists. Another exoplanet, first identified in 1988, was confirmed in 2003. As of April 2024, there are 5,653 confirmed exoplanets in 4,161 planetary systems, with 896 systems containing multiple planets. Many of these discoveries are orbiting M-type stars. To understand what this means, it's important to know that an M-type star is the smallest kind of star in the main sequence, thus the name red dwarf. Red dwarfs are the most common stars in the Milky Way, but they have low luminosity, making them hard to detect, which complicates our search for planets. These stars have varying arrangements and names based on their size and temperature, like M dwarfs. Proxima B has a mass that closely resembles 1.07 times that of Earth. Interestingly, it only takes 11.2 days to complete one orbit around its star, compared to Earth's 365.25 days. You can assess the size of the star Proxima B orbits by considering the full electromagnetic range. The star's all-out radiance is a simple 1.6% of the Sun's splendor, and in the noticeable light range, it just sparkles at 5 to 6% of the Sun's force, delivering undeniably less light energy contrasted with the Sun. More than 85% of its radiated energy is infrared radiation, rotating around a scope of 0.045 to 0.056 Australian dollars from its star. Proxima B's revelation was declared in 2016, yet what compels it to stand out from the large number of other stars, planets, and worlds in our cosmic system? There are a few motivations behind why space experts are especially zeroed in on Proxima B, most eminently because Proxima B is the closest known exoplanet to our Sun. While 4.2 light-years may appear to be far off to us in the tremendousness of the universe, it is relatively close. Proxima B is essential for the Alpha Centauri star system, a triple star system, and regardless of its low splendor, it is still one of the most brilliant objects in the night sky, following only Sirius and Canis Major. What makes Proxima B even more charming is its possible livability, as it dwells within the star's habitable zone, the district where conditions might be appropriate for liquid water to exist. This probability has prodded serious interest among space researchers, prompting further investigation of the system's potential to support life. This is where the James Webb Space Telescope comes into play. The 4 essential objectives of the JWST are to look for light from the first stars and worlds that shaped after the Big Bang, concentrate on the development of the universe, examine the development of stars and planets, and analyze planetary frameworks and the beginnings of life. As the JWST continues its investigation of exoplanets like Proxima B, we move closer to understanding these objectives. Looking for extraterrestrial life is presently a priority for the mission, which is especially pertinent given humanity's intrinsic interest. Investigating the unexplored world is a natural extension of who we are as a species, constantly questioning, examining, and investigating everything that moves or stays still. It makes perfect sense that a mission like this would be undertaken on such a grand scale. Envision the grand task before us, with a tremendous universe filled with vast possible outcomes. We are lucky to be the ones searching for signals from far-off civilizations. The search for extraterrestrial intelligence can be compared to a high-stakes game of vast, find the stowaway, with humanity as the searcher and the universe as the hiding spot. Scientists in this field are similar to talented investigators, checking radio transmissions for any weak murmurs of intelligent life beyond Earth. This effort began during the 1960s when famous astrophysicist Frank Drake first detected radio waves from the stars. While no extraterrestrial visitors have shown up yet, the inquiry continues. The mission for extraterrestrial signs requires patience, often crossing many years or even centuries. Not many conclusive extraterrestrial signs have been found. However, the journey continues to inspire hope, especially as the James Webb Space Telescope gathers data from exoplanets like Proxima B. This expanding field of investigation might one day lead us to confirm the presence of extraterrestrial life, or perhaps we will only receive questionable signals that leave us with more questions than answers. In any case, the detection of lights or signals from distant worlds like Proxima B could mark the next giant leap in humankind's everlasting interest, where the quest for knowledge and technological advancement meet in an exciting, invaluable cosmic adventure. As we continue our pursuit, we remain hopeful that one day we will find conclusive proof that we are not truly alone in the universe. The discovery of artificial lights or other signs from distant exoplanets like Proxima B would be a monumental step toward answering one of humankind's most fundamental questions. Are we alone in the universe? As the James Webb Space Telescope continues its work, its discoveries will undoubtedly spark further conversations, research, and maybe even challenges to how we understand life, intelligence, and the very nature of the universe. The possible implications of these revelations go far beyond curiosity alone. The chance of confirming life on Proxima B or another exoplanet would drive us to reconsider our place in the universe. Could life on different worlds evolve in ways similar to our own, or would it represent something completely unique? Would these life forms follow recognizable patterns of development and advancement, or would they challenge everything we know about science and consciousness on Earth? Regardless of whether we find immediate evidence of intelligent life, the mere detection of artificial lights or signals from distant planets would still carry significant implications. It would imply that intelligent civilizations exist elsewhere in the universe, potentially capable of modifying their surroundings in ways we can recognize. This would suggest that intelligent life is not an anomaly, but instead an inevitable outcome of specific circumstances in the universe. However, as exciting as this potential discovery is, we must approach it with caution. The confirmation of extraterrestrial life raises various questions, including how we should respond. How might humanity react to the discovery of intelligent life? Will we approach it with respect, interest, and scientific diligence, or will the revelations incite fear, panic, or even political struggle? History has shown that new discoveries, particularly those that challenge long-held beliefs, can provoke unusual reactions. As we venture further into space, it is crucial to consider the moral and ethical ramifications of our search. If we do find life, especially intelligent life on another planet, what responsibilities do we have as stewards of Earth? What moral principles should govern our interactions with other forms of life, whether microbial or advanced? These questions may not have straightforward answers, but they will undoubtedly be vital to the ongoing conversation as humankind continues its journey into the stars. The search for life beyond Earth, driven by instruments like the James Webb Space Telescope, is an exhilarating convergence of science, theory, and humankind's future.